Is there really a colossal megasun lurking at the heart of our Milky Way galaxy? What if I told you that scientists once believed exactly that, and the truth is even more mind-blowing? Stick around, because by the end of this, you'll uncover secrets about black holes, rogue planets, and the fate of our entire universe that might just keep you up at night wondering what's out there. Let's dive right in. Picture this, the brightest spot in our galaxy, crammed with millions of stars in a tiny space. What is this mysterious region? It's called the galactic bulge, a dense, bulging core that's the powerhouse of the Milky Way. Why is it so packed? When galaxies like ours form, gravity pulls vast clouds of gas and dust together, sparking star birth in a frenzy. Over time, this creates a flat disk with arms spiraling out, but the center stays bloated and bright. How dense are we talking? In the bulge, stars can be just 5 light days apart. Imagine another star hanging out beyond Pluto in our solar system. That's 10 million times denser than our quiet neighborhood. But here's the hook. Why does this density lead to something as terrifying as a supermassive black hole? Stars live, die, and collapse, and the remnants gobble up everything nearby. Our own black hole, Sagittarius A, is a beast 4 million times the Sun's mass, yet tiny, about the width of Mercury's orbit around the Sun. Don't worry, it's not sucking us in anytime soon. But why can't we see this blazing center with our naked eyes? It's 26,000 light-years away, shrouded in cosmic dust that blocks visible light. How do we peek through? Scientists use infrared, gamma rays, and X-rays. NASA's images reveal a scorching inferno that would blind us without that dusty veil. Imagine if that dust vanished. The night sky would glow eternally white from the bulge's brilliance. As we zoom out from the center, things calm down. Where are we in this vast setup? Earth sits in the Orion Arm, a spiral tendril far from the chaos, with stars spaced 4 to 5 light-years apart. Most of the galaxy? Empty blackness. But what if you lived closer to the core? The sky would be a perpetual daylight blaze from nearby stars, brighter than a full moon. Why no life there? Gravity's wild tugs make stable planets rare, radiation spikes from supernovas fry everything, and dense gas chokes the air. Yet, some galaxies shine even brighter, not from stars but from active galactic nuclei, AGN. What are these? Hyper-energetic cores where supermassive black holes feast on spiraling accretion disks, heating gas to emit insane energy. How does it work? Friction and gravity turn the disk into a cosmic furnace, spinning near light speed and blasting jets of particles. Think quasars, the ultimate winners in brightness, outshining entire galaxies visible billions of light-years away. Why so luminous? Their black holes are gluttons, devouring matter and spewing radiation that's a beacon for astronomers. But quasars aren't the biggest structures. What if I said walls of galaxies span billions of light-years? Take the South Pole Wall, 500 million light-years from Earth, packing a quadrillion stars. How was it found? By measuring redshift, the stretch of light from expanding space post-Big Bang. Larger still, the Hercules Corona Borealis Great Wall, 10 billion light-years wide, detected via gamma-ray bursts, rare cosmic explosions signaling dense galaxy clusters. Zoom further. Our local group includes the Milky Way, Andromeda, and dozens more, bound by gravity over 10 million light-years. Then the Virgo supercluster, 20 times bigger with 30,000 galaxies. Keep going to Laniakea, home to 100,000 galaxies, and the Pisces Cetus supercluster complex with millions more. The observable universe, over 500 billion galaxies, a billion trillion stars, woven into filaments separated by voids, empty expanses vaster than imagination. One void, the Eridanus supervoid, is a billion light-years wide, possibly a scar from colliding universes. Why? Theories suggest our universe is a bubble among infinite others. A touch could rip matter away, creating cold spots. How to travel between? Wormholes. Space-time folds like punching through folded paper. But surviving? Pick a supermassive black hole. Its gentle gravity gradient might not spaghettify you, potentially spitting you into another reality. Mind-bending, right? What laws might rule there? Now, for the scariest, rogue planets. What are these nomads? Worlds ejected from star systems, drifting sunless through eternal night. Why so terrifying? No light means frozen surfaces, no life, lonely orphans born from chaotic formations or supernova blasts. How many? Billions in the Milky Way alone per simulations. Detecting them, tricky, no star to dim or wobble. Instead, gravitational microlensing bends distant starlight, magnifying it briefly. One rogue, just 20 light-years away, boasts a magnetic field 4 million times Earth's sparking auroras, possibly from a moon. Could Earth go rogue? Unlikely. But an intruder planet might shove us from the sun's habitable zone, freezing us into an icy tomb. Resources dwindle, species vanish, darkness eternal. Speaking of fire and ice, is the Milky Way on fire? What does that mean? A halo of gas at millions of degrees surrounds us, heated by supernovas from star formation. Why so hot? Exploding stars blast energy, creating turbulent cycles of heating and cooling. Recent finds, a second, hotter layer via X-rays and quasar absorption. This gas recycles elements like sulfur and neon, fueling new stars. But our galaxy's shape? Not a flat disk, warped edges from ancient collisions, or a tilted dark matter halo. What is dark matter? Invisible mass dominating galaxies' gravity. Simulations show tilted halos persist billions of years, twisting disks, seen in half of spiral galaxies, fuel for stars. Fast-moving hydrogen clouds rain into the disk, ionized and vast, 110 million suns worth. Where from? Primordial Big Bang remnants or recycled supernova ejecta. Future telescopes will reveal via chemistry. Our black hole might be leaking, jets spewing gas like a blowtorch, inflating bubbles from past feasts. Active after all. Observations suggest hiccups from swallowing clouds millions of years ago. Bizarre spots await, black widow pulsar, devouring its companion brown dwarf. Nuclear pasta in neutron stars, strongest stuff, needing billions times steel's pressure to break. Glass-raining exoplanet with 5,400 mpm winds. Solar tsunamis of plasma from magnetic clashes. Electric Hyperion moon, static charged and cratered. Micro black holes, atom-sized but sedan-heavy, possibly zipping through Earth daily. Burning ice planet Gliese, 436b. Water as ice X, solid at 800 degrees from gravity. Diamond planet, carbon crystallized denser than any known. Submoons, possible if moons are massive enough. Living fossil galaxy DGSAT 1, sparse and ancient, formed post-Big Bang. Infrared streams from neutron stars, mysterious Kuiper belt patterns hinting at Planet 9. Sun's atmosphere hotter than its surface, blame explosive bursts. Haumea, fast-spinning dwarf with rings. Fast forward, in 7.5 billion years, the sun expands, swallowing inner planets. But humanity flees earlier, to exoplanets in habitable zones like Proxima Centauri's worlds. How to get there? Rockets take millennia. Light speed impossible for massed objects per physics. Enter warp drive, bend space-time compressing ahead, expanding behind. Recent tweaks suggest donut-shaped fields work on small probes, reaching 10% light speed, Alpha Centauri in 44 years. Alternatives, laser drones, nuclear antimatter collisions, ion propulsion for efficient acceleration. First, Mars colonization, terraforming tests, warm it, boost pressure, add ozone. Master that, then interstellar leaps. Our galaxy's size? 200,000 light-years across per models and halos. Thin pancake galaxies like ESO 3738, star-forming via spinning gas collapse. Some strangle, gas-stripped in clusters, halting star birth. Planets aren't perfect spheres. Gravity versus spin bulges Earth. Tilt from ancient impacts causes seasons. Venus spins backward, day longer than year. Comet strike. Moon's tidal lock shows one face. Uranus sideways. Rings once stabilized it. As we wrap, ponder. What unseen wonders await? From bulging cores to rogue worlds, the universe teases endless mysteries. Keep watching the skies. Who knows what you'll discover next? The universe is vast, mysterious, and endlessly full of surprises. From the blazing heart of our galaxy to lonely rogue planets drifting in the dark, we've only scratched the surface of what's really out there. Every new discovery reshapes our understanding of space, time, and our place in it. Could there be other civilizations watching us from afar, or forces beyond science waiting to be uncovered? The truth is stranger than we can imagine. If this journey blew your mind, don't forget to like, share, and subscribe for more cosmic explorations. Until next time, keep your eyes on the stars and your curiosity alive.